5-4, number 7 and 9, they want you to fill in these values. One of the things that the video showed you is that cofunctions, these are cofunctions, cosine and sine. They're not reciprocal functions. They literally are the same function with the co in front, cosine, sine. Cotangent, tangent. So on either side of this equal sign, we have cofunctions. If you have cofunctions and you have an equal sign in between, then what we know is that these angles here have to be complementary. What it means to be complementary is that they are two angles who equal 90 degrees, or in our case, since we deal with radians, equals pi over 2. So this angle plus this angle has to equal pi over 2 because these are cofunctions. So we're going to take pi over 3, add it to some angle to get pi over 2, which means if we want to know what that angle is, we're going to have to subtract pi over 3 from pi over 2. So this is going to become 3 pi over 6 to get a common denominator, 2 pi over 6, again to get a common denominator of 6, and when you subtract those, this becomes pi over 6. Same thing over here. These two angles are going to be complementary, which means this angle plus this angle is pi over 2. Since this angle is pi over 4, then I need to figure out what angle to add to it to get to pi over 2. So what I'm technically doing is taking pi over 2 and subtracting pi over 4. When I get a common denominator there and subtract, I get pi over 4. The next section, they want you to solve this for these sides. Now, I did take the information and drew a triangle out of it. A couple of things you need to know about these triangles is that angle C is always the right angle. Angles A and B are the acute angles. And the side that corresponds with angle C is labeled little c. The side that corresponds with angle A, the one that's across from it, is little a. Angle B, side B. So they told me and gave me what angle A was and what side B was, so I labeled those in there. So what I need to do is I need to figure out what side A is and what side C is. Doesn't matter which one you do first. I like to go in alphabetical order, so I'm going to find side A. So I need to figure out, given this angle, what is A? Is it a hypotenuse? Is it an opposite? Is it adjacent? Well, A is opposite, angle A. And then I need to figure out this side. This side, is it the hypotenuse or is it adjacent? It is adjacent. The trig function that has to do with opposite and adjacent is tangent. The tangent of any angle is opposite over adjacent. So now fill in the stuff. Tangent of 78 degrees equals the opposite, which is A, over the adjacent, which is 3.5. And then we solve this. So multiply both sides by 3.5. I already made sure my calculator was in degrees. So I have 3.5 times the tangent of 78. And they told me to go to 4 decimal places. So side A is 16.4662. And then now that I have that side A, 16.4662, I have a right triangle here. I have 2 of the 3 sides. I'm missing side C, which is the hypotenuse, so I can go on and use the Pythagorean theorem. So A, 16.4662 squared plus B, which is 3.5 squared, equals C squared. So I'm going to take this previous answer and square it, and then add to it 3.5 squared. And then I'm going to take the square root of that. And I get 16.8341. And there you go. Now for this next one, they want to know what side X is equal to. Now, the triangle here that side X is a part of, which is this triangle right here, is not a right triangle. So I cannot do anything with right triangle trig there. I can't try and do SOHCAHTOA or anything like this. So what they want me to do is they want me to see that what I have here is I actually have two separate triangles. I have this obvious right triangle, this little tiny one, where I could find this little piece right here, which is this piece right here. So opposite over adjacent again, as we compare to this, we got opposite, adjacent, so we have the tangent of 70 equals opposite over adjacent. Solve this, adjacent equals 119 over the tangent of 70. And you're probably saying to yourself, oh great, what does that tell me? Well, it tells me right here, this piece is 43.3125 whatever units long. My other triangle that I have here, my other right triangle that I have is this triangle right here. And that triangle which also has that leg of 119, has this angle of 26. And when I solve that triangle, what I end up with when I solve it for this value right here is whatever this value is happens to be that plus that. So if I solve and figure out what this is, let's call it y, then I can calculate what that little missing piece is. So I'm going to calculate this by doing the tangent of 26 equals 119 over y. So y is 119 over the tangent of 26. So that whole thing then, this whole piece, y is equal to 243.98, blah, 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 blah. But I don't want this whole thing. I don't want y. I only want x. So if I know this whole thing is 243 point blah, 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 and this little piece is 43, da, 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 and I want x, then I'm going to take that 243 and I'm going to subtract from that the 43.31 blah, blah, blah. And that gives me my resulting 200.6737. Okay, and then the last one that we had, I again started drawing. This was a story problem here. It is that there's a monument that's 400 feet tall, so that's my monument. There's a person some distance away standing right here. When the person looks up to the top of the tower, it's an 18 degree. When they look down to the bottom of the tower, it's a 3 degree. So this was an angle of elevation, an angle of depression. They want to know what this distance is between the person and the tower. Again, this distance right here happens to create two right triangles, but this outside one is not a right triangle. So what I have is I have the top triangle, which is that, and I don't know how tall this leg is because I just know this whole thing is 400. And then I have this second one, which this is also D, and this is 3 degrees. But again, I don't know how tall this is because I know this whole thing is 400. So what I'm going to do is I'm going to call this piece X, which means if this is X and this whole thing is 400, then this little piece is 400 minus X. Now watch what I can do. If I use right triangle trig, sorry, and I write two trig functions here, so I have 18, the opposite leg and the adjacent leg, so I have tangent of 18 is X over D, and I write one here, again, here is 30, opposite leg, adjacent leg, so tangent of 30 equals 400 minus X over D. And I solve both of these. I'm going to solve both of these for D because that's what I want to know. And you're saying to yourself, well, wait a minute, you have two variables here. I know, it's okay. Let's just solve both of these for D. So if I solve this one for D, I get D equals 400 minus X over the tangent of 30 degrees. If I solve this one for D, I get D equals X over the tangent of 18 degrees. Well, what I end up getting then is I end up getting two equations that equal the same distance. Two different equations, but they equal the same distance. So I can take these two equations and set them equal to each other. And then I can solve this proportion. So I can take tangent of 18, tangent of 30, change those to decimals. So I just put those in there. I'm going to just replace those. So I'm going to have X over the tangent of 18, which is 0.3249, equals 400 minus X over the tangent of 30, which is 0.5774. And I can solve this. It's a proportion. In a proportion, the cross products are equal. So this cross product is going to be equal to this cross product. So 0.3249 times 400 minus X. We're going to distribute that. I'll just multiply that right now. So I'm just using the calculator and multiplying this times 400, and I got 129.9679 minus, and then I'm going to distribute that. I know they're yucky decimals. Life isn't all about really nice decimals, okay? Then I'm going to move all my X terms to one side, so I'm going to add this over. So I'm going to add those. Just doing that on the calculator off to the side. Equals 129.9679. Whoops. And then divide both sides by this. So again, I'm just going to do that on the calculator. So 129 divided by 0.9, blah, 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 blah. And when I do that, I get X equals 144.0454. Now that X there, if we go back and look at that, that X is this distance right here. That's not what we were trying to solve for. We wanted to know what D was equal to. Well, I can figure out what D is equal to by taking that X value, putting it in here, and dividing it by the tangent of 18 degrees. So again, I'm taking that X value and I'm on my calculator dividing by the tangent of 18 degrees. And then that gives me my distance, because that's what D is equal to according to my formula. So that tells me what the distance is between the person and the tower. 443.32 feet.